Hello, together. Let's wait one more minute. By the way, do you hear me?
Yes, I can hear you.
Yeah. Ah, thanks. Fine. Okay, then we can start. First of all, a warm welcome to all of you and welcome to the next Gardener community meeting. Today I will jump in for Matthias, which is not here, and can hopefully host the next meeting. So today on the agenda, Prashant and Gaurav will give an overview of the machine controller manager and the 5 point, which you see on the list, and afterwards we can trigger a discussion. Is somebody new to the Gardener meeting, or is it the first time for someone here?
Yes, for me it's the first time. Hi, this is Daniela from Dynatrace. So we learned about Project Gardener already some months back, and we saw a presentation during Cloud Foundry Summit in Basel. And here we are now attending the community meeting the first time, and we will hopefully also provide some input here as well once we have really investigated Gardener on our side.
That sounds great.
Cool.
Somebody
hello.
else?
Hello, everybody. This is Michal Jura. I'm a Kubernetes developer from SUSE. So I participated 1 year ago on the SAP workshop, and where we could learn a little bit about the Gartner project. And yeah, right now we would like to join and to see what is happening with this project, and yeah, probably to give also some feedback and input, and probably join the community.
Thank you, Michael or Michelle. So then I will hand over to Prashant and Gaurav, and you can start.
Okay, hello everyone. So what we have for today is I'll probably try to give an overview of what machine controller is all about and how it fits into the Gardener architecture, and maybe I'll speak about bits and pieces of the autoscaler as well. Maybe we'll just go through the slide deck, and then I can have a short demo and show you how it all fits in, right? Stop me if you have any questions in the middle or at the end. Feel free to stop. Okay. So just a quick overview of Gardener architecture. I thought it would just help anyone who is new to the meeting, as well as understand how the machine controller manager fits in the Gardener architecture, right? So we know that a Kubernetes cluster has master and worker components. So assume these hexagonal boxes as nodes. So we have master nodes and worker nodes. So we have a similar configuration, and we call this one of these clusters as a seed cluster. And we have, just might be a recap, just I'll try to skim through it, right? And what we have is from the seed cluster, we spin up something called as shoot clusters, which have the worker minions. So the shoot clusters are something that, so the seed cluster is like a centrally managed cluster for us, which is the management cluster, and shoot clusters are the clusters that you provision to your end users. So they also have some workers. And now if the shoot clusters workers are here, where are the so we have many number of shoot clusters that can be spun up by one seed cluster. Now, where is the control plane of the shoot cluster? That's in the seed cluster. So in the seed cluster worker minions, as you can see here, we create a namespace for each shoot cluster created, and we deploy the control plane for that in the seed cluster shoot namespace as mentioned here. So in the control plane, what are the components that we deploy are typically, these are your core Kubernetes control plane components like etcd, kube controller manager, scheduler, API server, a few more, maybe like cloud controller manager and things like that. Along with that, what we also deploy is something called as machine controller manager, which is responsible for maintaining the set of machines attached to a particular shoot cluster. And then we also deploy something as a cluster autoscaler, which is responsible for scaling the set of machines attached to that cluster, right? So this is how I just showed you this so that you understand where the machine controller is spun up. So there is one machine controller, MCM, or machine controller manager, we call it as MCM, created per shoot cluster that is deployed, so that there's one controller taking care of the machines attached to one particular shoot cluster, right? And then we have something as a garden cluster, and which actually hosts your garden controller manager and your garden API server, the Gardener's components, right? So just a brief overview for anyone who's new, right? Does anyone have any questions up till here? I take that as a no. I'll move forward. So yes. So now that you understand like where the machine controller manager, the component that we are talking about today, fits in, let me just talk to you about the resources we use to manage these machines in the cluster, right? So we have something called as a machine CRD object, which we create. There are a lot of fields. I've skipped a few fields. I just kept the important fields. So you can create a machine CRD, you can give it a name, you can give it a machine class. So what is a machine class is, for us, it's like a machine template from which a new machine is spun up. So for example, if you're trying to create a machine, you create a machine class associated with it. The class is like a template where you say what type of machine it is. If it's, say, for example, in this case, an AWS machine, M4X large, what is the disk size, and other infrastructure related specs that are required while deploying AWS virtual machine. What is interesting is we have something called as a secret as well, which is nothing but a Kubernetes secret. Now, what the secret holds are two main components. One is your cloud provider secret, which is your IaaS specific secrets that it holds. And what we also have is we have a cloud init script. This is the initialization script, which contains all the details that any VM that you're trying to spin up for this cluster should have. This also includes the kubelet version and so on and so forth. So this is the simple flow. So you get it, right? So we create a machine CRD object and then a machine class, and the machine class has its machine secret. Similar to this, so this is for creating a single machine. Similarly, we have taken the analogies of pods, replica sets, and deployments and applied the same thing over here. So a machine can be thought as similar to a pod. Similarly, we have something called as a machine set, which is a set of where you can say, I want a set of machines, say three machines with the same machine class type, right? Similarly, you can always have, similar to the pod deployment, we also have the machine deployment, which will also take care of the updating strategies. So for example, you can say a rolling update or a recreate and things like that, right? Maybe I'll just put this all, I have a quick slide to show you how all this fits together, right? So say, for example, this is your cluster, you have a Kube API server, etcd, right? With your kubectl, what you can do is you can go ahead and create the machine class and the secret that I showed you in the previous slide. Let's call these objects as version 1, machine class version 1, machine, and a secret with version 1, their names, right? We create them, we do a kubectl, create these objects, these CRDs, they get stored. Now we create a machine deployment. Say I reference this machine deployment to this class. Let's call it V1, right? And say I want 3 replicas of this machine deployment. When this is there, what happens is there's the machine. We have a controller called the machine deployment controller, The machine deployment controller is similar to the deployment controller we have in Kubernetes, upstream Kubernetes. Looks at this, creates the machine set object required for it. And now the machine set controller looks at it and creates 3 machine objects. Then we have a machine controller, which looks at these machine objects and talks to the cloud provider, spins up the required number of VMs. Right now, the MCM supports 5 cloud providers: AWS, GCP, Azure, OpenStack, and Ali Cloud. And yeah, it goes ahead, spins that up. Once these VMs come up, it talks to the KCM and it creates node objects. So one thing you should to note is that the machine objects and the node objects are, so the node objects is an understanding of machines in terms of Kubernetes, and machine objects is something CRDs that we have created, right? So it spins up node objects. Now what we do is we monitor these node objects corresponding to the machine objects to take care of the health, right? So we do health checks using these node object statuses. So whatever these controllers, these small sub-controllers that I was talking about, all bundle up to a larger controller called as a machine controller manager, what we refer to as MCM over here, right? Any questions up till now? Okay, so moving on. So yeah, take the same scenario, same setup quickly to just explain you how autoscale would also kick in. So say for example, you had 3 nodes in your cluster and it's all filled up, and all the node resources are nearly consumed, right? So and say for example, now a pod is created. Let's take it as an Nginx pod, and now once this pod is targeted for scheduling, it realizes the scheduler realizes this is not schedulable, right? So this is where we have a forked version of Autoscaler. The community has a cluster Autoscaler project, which actually by default talks to cloud provider specific autoscaling groups like ASG, AWS ASGs or GCP mix. So what we have done is we have just forked it a little. We've just added just a couple of files. So there's this interface, there's a cloud provider interface where it lets you allow you to support a new cloud provider. We have just added a new cloud provider and we have called it MCM. What it does is it looks at this pod that is unschedulable, updates changes the number of replicas based on load on the cluster, talks to the MCM, realizes, okay, there's a change in number of replicas, talks and it creates a new machine object, talks to the cloud provider, and the same flow goes on again and the node joins, and this pod is now scheduled onto the new node, right? So this is how the autoscaler fits into the whole picture. So yes, so this is the basic overall working of MCM and autoscaler in general. Now I'll just get into a few more details so that it's a little more informative. This many of you might already have known about this, so maybe we'll talk more about the nitty-gritties of MCM in general, right? So what do we have in addition to, I spoke about 3 controllers earlier: the machine controller, machine set, and the machine deployment. And what we have is also another additional subcontroller, which is just a parallel controller running on the side. What it offers is 3 features. One is it has this what it does is it has this orphan VM handler. What it does is it terminates any orphan VMs that are spawned in the provider. So say for example, your MCM was running, right, and you created a machine object, and now the machine object so it tries to create this machine on the cloud provider, and when it issued a create call, now the machine controller goes down, and before it could get a response from the cloud provider, the machine controller was down and your CRD couldn't be updated, right? So you lose state of that VM that was actually created on the cloud provider but was not picked up by your MCM. So to handle situations like this, and yeah, we have seen some occasions where such scenarios occurred where we found some orphan VMs on the provider. So to handle such situations, what we have done is we have this orphan VM handler. What it does is it has a map of existing machine objects and the VMs on the provider. And if we see that any VM that is not mapped back to a machine object, we find any such VMs, we terminate them. How we do this is we use labels on the VMs that are being created by MCMs, and we try to map them, right? What we also have in this safety controller is a mechanism to restrict overshooting of machine object spawn. So maybe I'll give you an example to set the context here. Say, for example, you created a machine deployment and you said you want to have 10 replicas of it. And for some reason, there's something wrong with your code or something going wrong all over the cloud provider. And it so happens that you spin up hundreds of machines instead of 10 machines. At this point, it just goes on spinning up 100 VMs also at the cloud providers, which could be expensive. So to avoid such a scenario, what we also have is restrict this overshooting of machine objects. So for a given machine set or a deployment, say for example, you have a machine deployment of 10 objects, at max we allow spinning up of 10 plus whatever your surge is specified on the deployment. If there's a deployment exists, say your max surge is 2, and we have another setting where we can set plus or minus 1, say, I mean, that is also configurable. Maybe I'll talk about it later. So you can have maximum of say 12 or 13 machines. And if it goes beyond this, what the MCM does is it kind of freezes only this particular machine set or machine deployment. And say, for example, once the machine set or machine deployment reaches back to 10, it unfreezes it. And the freezing logic is little interesting in the sense that we only freeze the scale up and not the scale down, thereby allowing it to stabilize itself even if a situation like this happens, right? And what we also are currently working on is, there's already a PR pending on is so we saw the scenario where many times the API server was not reachable. So at this point, what the MCM would try to do, it would try to reconcile the set of machines that it has. So what we do is, for the health checks, we actually rely on the node object, right, as mentioned earlier. So when the API server is down, it thinks that the node is unhealthy and it starts trying to recreate these machines or tries to meddle with it. So there's a lot of recreations and unwanted recreations going through. So to handle this scenario, we freeze the machine controller whenever the API server is unreachable, right? So these are as you can see, these features are little very specific features and have nothing to do with the typical pods or replica sets or deployment controllers. So we have just bundled them up in a safe controller called Safety Net Controller, right? Yes. So moving on, just
to add on that point, right? So the motivation behind Safety Controller is not just these cases, but the larger perspective is also that when we will be adding more and more cloud provider, right? At some point, we want to rely as less as possible on the cloud providers' functionalities. So in case something is not interpreted properly from the cloud provider, then we should be able to somehow take care of the resources and not end up costing extra. So that's also a larger perspective.
Yes.
Thanks.
Okay. So yes, moving forward. So one thing I thought we could talk about is machine phases and health checks. So in a single line, so all this while I was talking about a healthy machine. Now, what does a healthy machine mean to us in MCM is, say for any machine which has its node object and has the kubelet responding in a ready state. As you know that the node has a lot of conditions. One of the condition is the kubelet condition, kubelet ready status. If the kubelet is reporting ready and there is no disk pressure on the machine. So and if these two conditions are satisfied, we treat it as a healthy machine. Why we take disk pressure also is because in our setup, in the general setup, Kubernetes treats machines as cattles, right? Like it doesn't depend on any stateful workload that you have is typically mounted on the volume itself, right? The PVCs. And so any machine that goes under this pressure we just wait for it for a while, or if it's not reporting ready status, and then if it's not able to come back up, say meaning the kubelet turning back ready, or if the disk pressure is not gone after some time, we just replace it, right? So yes, maybe I'll talk more about it while going through the phases. So yes, just for the definition. So for every machine, we have a face representing what the current state of the machine is. So the initial phase is a pending phase, which is similar to your pod pending. So this is to indicate when the machine is in a creation. And then we have something called as a pod running phase, which is similar to your pod running as well, where the machine has joined the cluster and the node is in a healthy state, meaning it's reporting kubelet healthy and there's no disk pressure again. And then we have a terminating phase when, say, for example, you have triggered a deletion on the machine object and it's being terminated on the provider, right? What we have in addition to this are two more phases. One is an unknown phase. So for example, we have a configurable timeout called machine health check timeout, right? So this is the timeout. This is the buffer period we give for a machine to for a machine to go unhealthy, and we wait for that buffer time. And if it doesn't respond in that time, we finally say that this machine can no longer be repaired, right? So we move to something called as a failed state, which I'll talk about later. So if a machine has been unhealthy for, say, let's take 5 minutes for now, more than 5 minutes, and at that point, when during these 5 minutes, it goes to this unknown phase. And say, for example, in the next 5 minutes, it manages to join again, it goes back to the running phase. But if by any chance, even after 5 minutes, it's not able to join, we move to something called as a failed state, which is like a final state again, from where it cannot go back to any other states. So at the failed state, it means that the machine has failed to report its healthy status during creation or a health check. And so, or even this could be in a failed state because, say, for example, a cloud provider, you try to create a machine on a cloud provider and the provider returns some errors, or even during deletion, at that point also this machine is under failed state, so that you can keep track of what is going on with your machine, right? So these are the machine phases, health checks that we have in place currently. Moving on. Any questions, any queries until now? Okay, we'll move on. So there are few configurable knobs that we have in MCM that we have exposed, but we have defaulted these values to something. So maybe I'll just talk about these knobs quickly so that it's helpful for any of you who wants to play around with it and try something more, right? So we spoke about this orphan VM handler. So this orphan VM check by default is run on two occasions. One is either if you just try to delete a particular VM. So that's this orphan VM handler is run by itself. That's because, say, for example, you try to delete a machine and accidentally the VM was not deleted. So we just run this orphan VM handler once then. And then we have a periodic check. So what it does is it polls during this time period. So for example, I think we defaulted to about 2 minutes or something, 2 or 5 minutes. I don't remember exactly. So where we poll every 5 minutes or so to check if there are any orphan VMs present on the cloud provider. Similarly, we have this overshooting period, which is the safety feature that I spoke to you earlier, where if the number of replicas exceeds some given number, we try to freeze it and then unfreeze it when it shoots below that. So this is also run periodically, and you can set the timer for this. And then this is the new feature that I spoke about, where it checks the API server status and freezes or unfreezes the MCM. So this also has a period that you can set. Then you have the machine safety. So this is the API server status check timeout. So what this means is that this is the timeout that you say an API server is allowed to be unreachable. Say, for example, an API server goes down, like sometimes the API server is not reachable, say for a few seconds due to some network delay and things like that, right? A network being down temporarily and things like that. So this is a timeout which you can configure for how long your API server cannot respond before it actually starts to freeze the controller. So by default, this is set to about 30 seconds, I guess. And there's this machine creation timeout as well that we are implementing, right? So the features marked in red are still under implementation, probably will be out in a week or two. So yes, the machine creation timeout is where the timeout used while joining of machines. So for example, you create a machine object and the cloud provider typically takes a few minutes to spin up a VM. So the time you wait for the VM to actually join, the maximum time that you wait for the VM to actually join is this machine creation timeout. We typically default it to 10 minutes. And similarly, we have a machine health timeout, which is a timeout used while joining of machines during health check. So I was talking about this this machine unknown state, right? So how long your kubelet can stop responding for a connected cluster. So that is this is that timeout. So it waits for, so right now it's also 10 minutes. So right now we have this single machine health timeout, which is used for both creation and health checks. So we are trying to split these out into 2 parameters so that you can have different controls over it. And then we also have a machine drain timeout. This is a timeout used while draining of machines before a forced deletion. So for example, you're trying to delete a machine, right? And before it deletes, it does a drain. But sometimes it so happens a drain is not possible. At this point, what it does is it waits this maximum of, we default it to 5 minutes. And if it's not able to do it in that, it forcefully deletes the machine without draining it, right? And lastly, we have 2 parameters. One is a safety up. So this is with reference to the overshooting, machine safety overshooting. So say, for example, you had, let's see what this upper limit is, right? So say, for example, you had a machine set or a machine deployment with 10 replicas, and you say it has a max surge of 1, right? If it had a deployment backing it. And then if you set safety up to 2, so your upper limit is 13. So if the number of machine objects goes beyond 13, hits 13, the controller starts freezing, right? I think it's beyond, right? So if it hits 14, it starts freezing. And now similarly, freezing is, so by freezing, it doesn't allow you to create any more machines backing that machine set or deployment. And similarly, we need something called safety down, which is for unfreezing it again. So for example, if your upper limit was 13 in this case, and you set your safety down to 3, so once the deployment hits 10 again, it unfreezes it.
So when it hits the upper limit, can you freeze the controller? Can you still downscale again?
Yes. So only the upscale.
It only freezes the upscaling. Okay.
Yes, upward. Yeah. You cannot upscale, but you can still downscale. So all of our freezes are that way. So that way we don't avoid. So for example, even if the machine controller or the machine objects are frozen by any chance, we still allow the possibility of deleting them, right? So that's the reason.
So basically, MCM tries to self-heal itself. So whenever there are more machines, so mostly we see this kind of situation happening where you basically try to delete the machine and cloud provider is not able to delete as expected. So in an expected time period. For instance, it's taking more than 5 minutes or 10 minutes, then you would see that you would have already created the new machine to replace the old machine in case those machines were failed. But when you try to delete the failed machines, they are stuck in the cloud provider. So then we take a call that unless those failed machines which are stuck in the deletion, we should not do anything else in terms of scaling up. So we freeze MCM till that point of time, the old failed machines are gone, and then the freeze label is removed again. So it's mainly coming from that perspective. So the safety down there helps that whenever the number of machine goes in a safe zone, wherever the way the safety down is parameter is set, based on that we will decide when to unfreeze. So most of these parameters are mostly defaulted in Gardener with 1 and 2, but based on the use cases, you can decide if you're testing out certain other kind of features, and you can have a more advanced uses or customized uses of MCM by using these modes.
Yes.
So just to understand, I think the other colleagues we had a chat with yesterday, they said they basically do not need a safety controller, but if I see it correctly, you are connecting with the health timeout, with the drain timeout, you're connecting it to the dynamic situation. So this actually would give you a good answer of why a safety controller is still needed. Do I see it correct, or do we have to rethink the question of how the others are looking at it?
So the the knobs here that have the safety word mentioned are the only ones with respect to the safety controller. These timeouts, these creation, health, and drain timeouts are something to do with the machine controller. It's the other parts of the MCM. So
yes, but to answer your question, Vasu, so this is actually correct. So if you remember, we also did not implement the safety controller even in the first version of the MCM. We also thought things should be fine. But as and when we see the weird behaviors coming from the cloud provider, for instance, this very simple use case I just talked about, you try to delete the machine and it's just not getting deleted. So what's the right thing to do there? So you should basically you should basically create a new machine, get your cluster in the healthy state in one way. But then on the other hand, because the older machine is still stuck in the deletion, you want to do something there and not let the MCM do the job ahead, right? So those are all.
But you could argue that this is something we could handle in a reconciliation, right? I'm just, but it doesn't answer the dynamic nature of it. Yeah. Okay.
Yeah. Okay.
Okay. So then moving forward, I think, yeah. So this is all what we have already. What we are working on right now is primarily we are trying to align our implementation with the cluster API. So for those who aren't aware of cluster API is a similar working group. What it does is it tries to spin up clusters, and they have a cluster API specified where they have a set of APIs which any controller should adhere to. And a subset of those APIs are machine APIs, which a machine controller manager like ours should adhere to. So what we are working on is we have a branch on MCM where we are trying, where we have adopted the MCM to understand the cluster API. And so we are evaluating how it works out, and we are trying to finalize the last few changes. And once we have that in place, our idea is at least so that MCM understands cluster API, and probably we'll have a migration plan to for the upstream, the MCM on the master, which can understand these cluster APIs, right? So, and not only that, not just that, we are trying to join their calls and try to contribute our part into the cluster API itself. And yeah, so Hardik is mainly aligned with those. And yeah, and you can see, if you click on this link, you can see that on the cluster API itself, in the API adoptions, we have been mentioned right now. And so, and then what we are also working on is out of tree support for new providers. So what it means is, like, right now, to add any new provider, we support 5 providers, as I mentioned earlier. And if you want to add any new provider, you would have to file a PR to the MCM repo itself, and this code will have to be verified entry. So what we are trying to do is get this provider specific code out. We're trying to get it done through gRPC, where, say you want to implement a new cloud provider, all you would have to do is implement 3 methods. So say get, create, and list. Get, create, and delete. So if you implement these 3 methods in a gRPC client, you would easily be able to plug this into the MCM and have MCM working for that new cloud provider, right? So we have these one issue and a branch tracking this as well. Hopefully we will have something there as well very soon. And so yeah, that's most of our important things that we're working on. And I thought I'll just give you a short demo or a glimpse of how it all fits together with Gardener, right? Yes. So for the demo, there are a lot of terminals that I have. Maybe I'll just explain them one by one so that you can make sense when I give the demo. So on top right now here, I have the logs. For what I'm going to do is I have a cluster that I've already spun up using the Gardener, and this is using my local Gardener. and I've brought the Gardener down so that it stops reconciling this cluster. So what I have is so this cluster is up. There's an MCM running for this cluster. So maybe I'll show you the control plane of this cluster. So I'm just on this particular window, I'm just going to have a watch on the shoot control plane. Right. Yeah, it's a little slow. Just bear with me. Yeah, there it is. So yes, so as you can see, this is what a control plane of each shoot would look like. These are the different components that are deployed. What I would want you to focus on right now is, you can see there's an MCM running, and this is for one particular shoot. I'm calling it cluster API. It's one of the shoots that I had already created. And so I have the machine controller manager running here, and the cluster autoscaler as well running here, along with the other control plane components. Then what I'm going to do is I'm going to have a watch on the logs.
Why did the cluster autoscaler have 94 restarts? Were you trying something, or is that?
The reason being is probably because when we do updates, we kind of when we do cluster updates via the Gardener, we kind of restart the cluster. Or maybe the API server was down. Maybe that's the reason. Like I mean, this is just a test cluster that I have running locally. So what happens is, if the API server is not reachable, it starts going into this crash loop back off. So I guess that's the reason this has too many restarts. Okay. Yes. And so what I'm going to do is I'm going to have a watch on the logs of the machine controller manager. So there goes that. And that's just some warnings and some, yeah. What I'm going to do is so I spoke to you about the machine deployment. So in this cluster, I have just one machine deployment. I'm just going to have a watch on the replicas of the machine deployment. So you will see two replicas. So since I can't expand it over here, or maybe I can quickly show you what the machine deployment looks like. So this is what a machine deployment CRD would look like. So here you have the kind of machine deployment, this is CRD. And we have finalizers and namespace. So this is the more interesting part, the spec, where we have min ready seconds and replicas, how many replicas you want, the selectors similar to how you have in the deployment spec for pods, and strategy, what strategy you want while having your rolling updates, how many max search, how many mats unavailable, and things like that. And then the template, the same thing with this matching with the selector. In spec, this is where we have the class, where you say, I want a machine class of type AWS machine class of type X large machines, right? And the status is more to do with the controller. So for example, you can see that there are two. So this particular replicas, the desired is 2, and we're having the status as 2 available replicas are there. These are the conditions. Yes, the deployment has minimum availabilities, ready replicas, and then updated replicas, right? So this is what the replica would look like. So the machine deployment, similarly, we will, maybe I won't show you the complete spec. We will also have machine set backing this. So in this case, there are 2. That's because, say, for example, you do an update of your machine deployment, similar to deployments, it would create a new machine set and do the rolling update and things like that. I'd done an update a few hours ago. And then you would also have your machine objects backing them, right? As you can see. Okay, so what I will do is maybe I can quickly show you the machine object, just quickly, not too deep detail. Maybe I'll focus on the spec and yes. So you can see one is expected thing is we have an owner reference to the machine set, that is, it's backed by it, right? And in the spec, you can see the class as well as earlier, and you have a provider ID, which tells what's the provider, what's the instance ID, and things like that. And then what we have is on the status, we have the conditions. These are the conditions that we have just copied over from the node itself to maintain our health checks, so that even if we lose the node object, we still have the last condition status. And then this is the phase I was talking to you about, where currently it's running. And this is the last operation stat, where it says, okay, the last operation was a machine joined the cluster successfully. It was a create, right? Okay. Having said that, maybe I will just jump back to the watch on the replicas, right? Okay, this is the watch on the replicas of the deployment. And what I'll also have is watch on nodes. So whatever, till now, whatever I showed you, these are connected to the seed, right? And this is connected to the shoot itself, because we are going to get nodes. And then I'm going to do a get pods as well, right? Okay, kubectl get pods. So you can see there is already 2 pods running. So what I have running is, in the interest of time, is I have a pod which has a requirement of 1 node itself. So these nodes are, I think, of type X large. So they are 16 gigs of RAM. So what I've done to, I've tried to simulate a behavior where I can auto-scale the cluster. So what I've done is I've set the autoscaler min and max to 2 and 5. So right now there are two nodes in the cluster. And what I have done is I've deployed an Nginx app that requires 1 node by setting the requirement as 9 gigs and each node having 16 gigs. So it tries to map one to 1 pod and 1 node, right? So they are running happily because there are 2 nodes running, right? So what I'll try to simulate is so these are 2 terminals. One terminal I've connected to the seed cluster, one is to the shoot cluster, right? So as you can see, you will have this deployment here in the shoot cluster, right? You can see there's a one Nginx 1 node requirement with 2 desired. I'll try to scale this up. So if I try to scale this up by 1, hopefully the number of machine deployments should change and should be picked up by the MCM and try to create a new node, right? So I scaled it up by 1. You can see there's a new pending pod, and you can see that the replicas have changed to 3 because the autoscaler realizes, okay, as I showed you earlier, the load requires a new node and it increases the machine deployment replicas. And you can see the MCM's already received that create event and it creates a new machine. It takes about 2 to 3 minutes, about 3 minutes to join the cluster in case of AWS. So let's probably wait for 3 minutes to just see that this node joins and this pod gets scheduled actually. In the meanwhile, if you have any queries.
Just to add on that, so I guess this setup would be more for the demo. So you can always set up the timeouts, or I would say the time periods on when you want to do the scale up or scale down, right? So you can actually tell that, for example, for scale up, you want this much amount of time, or for scale down, you want to wait for this much amount of time before the actual scale down happens, and so on.
Yes. So you can, so Hardik, as rightly Hardik mentioned, you can set those timeouts on the cluster autoscaler itself. In the cluster autoscaler, in the configurable parameters, you can always set that. The waiting period before you actually do a scale up or scale down. So you can see.
I think you have forgotten to mention that you also put a number of logic elements into the scale down part. So when scaling down, you do have a prioritization of the machines, so that you don't take down the first best, but you actually take the one which you deem to be of the least priority.
Yes. So yes, as Vasu rightly mentioned, yeah, we do have some sort of prioritization while scaling down, and you can always override that priority as well using particular annotation. And what also I would like to mention is, okay, maybe it's just let me maybe quickly start the next thing that I wanted to quickly demo. and then talk about it. So yes, you can see the node has joined successfully. What I'll quickly do is on the same cluster, I have multiple AWS classes. So you remember this machine classes were referring to different machine types. So we could set machine types. So what I've done is I've created two classes. I've called it X large machine and large machine. So right now, so these are AWS machine types, right? So right now, if I look at my machine deployment, maybe I'll quickly show you. Can just try to edit it. So you can see in the spec here, the class name is X large machine, right? So maybe what I'll do is I'll try to edit this. I'll make it large machines. So what I'm trying to do is I'm trying to downgrade the clusters from maybe I'm just trying to downgrade it from X large machine to large machines. This use case could be more complicated, like you wanted to do an update of the kubelet versions or something else, like you wanted to increase the disk size of all your machines and things like that. So in this case, I'm just trying to move it to a smaller size of machines. So when I do that, you can see the MCM picks it up, it creates new machines. So this is a rolling update. So the update goes one by one. What is interesting and important that I would like to mention is when this rolling update is going on, it tries its best to adhere to any PDBs that you have specified on your apps. So for example, so how we do that is we use the drain logic, and the drain logic respects PDBs. So it tries its best. It tries its best effort. So it gives some 5 minutes buffer time for it to try to respect the PDBs and go ahead with the update. I mean, if it fails, it always forcefully deletes and goes ahead. This is especially important, useful if you have customers running applications which have some PDBs mentioned, which have some SLAs to adhere to, and you are doing an update on them. So this will just try to do it in more graceful manner, right? And yes, so you can see in the deployment, you can see the number of replicas are changing because these updates are going on. Maybe I'll scale these down for now. Let me just leave it. So yeah, it takes a very long time for the update to go through because it has, I don't know, not very long, but it will take a while. So in the meanwhile, we can take questions. Are there any questions? Comments?
Yeah, I have one question. So you showed a couple of configs, and are they available to be tuned from Gardener? Because when we are using Gardener, we can interact with machine control, machine deployment objects. Gardener maintains it, manages it.
So if you are using if you are creating, so how are you using Gardener? Are you using the upstream binary of Gardener to deploy it, or yes? What you would have to do is it's not too complicated, I guess. What you could do is just download the Gardener source code. Maybe I can quickly show you maybe. So yeah, yes, so this is the Gardener's repo. So what you would have to do is we have these charts, and we have seed control. You have all these charts that are running for a seed control plane. Here you have the MCM chart, right? And you could go to the deployment here. So here you can specify all your flags that you want to override. So these are defaulted in Gardener, right? So you can override these by changing this, and then you rebuild your Gardener with a make build, and then you can use that newly built image to run in your cluster. That way you can, I guess, make Gardener run with your new deployments with configurable deployments. Does that make sense?
Not really.
Not really.
Because if we will likely be updating these on a daily basis, or in a gardener deployment to another gardener's deployment. If these would be changing, I think this should be pushed as a configuration to gardener level.
Yeah,
this question is more about gardener, not about machine.
So I think the answer is that for so I think the answer there is that you cannot really customize all of the parameters for different shoot clusters for a single running Gardener instance, if that's what you are trying to say. But if there are strong use cases, right? If any of this parameter, if you see there are strong use cases for any of this parameter to be available at the Gardener layer, where the use cases that if you can provide such use cases, then maybe we can think of, and maybe we can provide these knobs at slightly higher level, where you can do things where a single Gardener installation can change such knobs for different shoots.
Yes,
I think more or less with the new and extensibility project, I think there we could think of having the controller, which then instantiates the machine controller in the various shoots to be configurable for various infrastructures, right?
Yes, we could do that as well, but I think we will definitely take your suggestion into account. I mean, I get your point. Maybe this should be configurable from Gardener using the Gardener component config, right? I mean, there is a configuration for Gardener available, the component config. Probably we could expose these back there as well, but we haven't really done it right now. But we can think about it.
Actually, I asked this just because we are mostly all on Azure, and on Azure, I was seeing nodes are they are actually flapping for some reason, which we didn't really dive in. Actually, we were talking about this in the chat.
Yes.
So you can tell it like it is. You need better timeouts on Azure.
Yes, I think we will need to tune pretty much most of this stuff for Azure environment, because Azure's API used to be slower than any other.
So
I'm not kidding. Sorry.
Yeah, that makes sense. So what we could do is, I guess, I don't think this is a lot of work, in the sense that what we'll have to do is, Gardener has its own configuration, component configuration, right? We can expose these parameters on the Gardener component config, and still allow Gardener to config like the other Gardener parameters, right? So I guess, we could do that. Even if it's a requirement for you guys, you could always file a PR and we'll...
Not yet. So please don't act.
Yeah.
I was just asking.
Yeah, and what is one more small thing I would suggest is, like, if it's a quick workaround, what you could do is, if you're with a situation like this with a running Gardener, what you could do is you could deactivate the reconciliation of that particular shoot that you want to test it on, using the Gardener's ignore annotation. And what you could do is you could basically go ahead and edit the machine MCM's deployment on the control plane, right? So you can see the MCM running here. You can just go ahead and edit this deployment and change the knobs there, right?
Yes, that's only for the testing purposes, right?
Yes. They wanted something to check, right? So if for some testing purposes, for checking certain things, you could the quick workaround could be that, is what I was suggesting.
Yes. Yeah, thanks for the idea. I'll use that for sure.
Yeah. But yeah, if you see that as a use case, feel more than happy to submit a PR or just raise an issue. We'll do something about it. Right. Any other comments, questions? Okay, if not, maybe I think we are done from the MCM part. Thanks. Thank you.
Yes, thank you very much, Hardik and Prashant, for giving insights into the MCM controller. So we have 5 minutes left. Are there some other points which you want to discuss shortly? Otherwise, we will end here the meeting, and thank you very much for attending the community meeting, and hope to see you next time again.
Bye-bye.
Bye.
Thanks, bye.
Thank you very much.
Thank you. Bye bye.
Bye-bye.